Hello, good morning, good afternoon. Yeah, everything works. Okay, let's get. Yeah, I'm just checking. Okay. Let's get to work. Part number 8 on the list of the tasks for today is to review the Ethernet block, to work on M2, SD card, and possibly peripherals. I don't know. We will see. I hope everything works. Yeah, comments. Okay. Last time I almost finished the Ethernet block, but yeah, as you can see, I kept a big note reminder for my future myself, which is my today's myself, to review it. And to review it means to check it against the original schematic, which is this one. Okay. Ethernet is here. So yeah, it's hard to review it or compare it when there are no windows besides of each other or next to each other, because otherwise it's quite difficult. But just signals going to a bus called ETH1, Ethernet 1, TDO, TD1, TD enable, RxDO, RxD1, Rx error goes to pull down only. That's interesting. Rx, okay, pull down 10K. Then CRS, MDIO, MDC, which is the last signal of RMII. Then reset negative, and reset goes to bus with the populated pull down 10K and unpopulated pull up. That's correct. I'm moving this farther from these text descriptions, and yeah, so I don't know what happened. Yeah, for instance, this works better. Okay, negative reset, pull down, interrupt negative, MD int called, yes, pull up to 10K, yes, clock xtel1 to Ethernet clock through 22 ohms of K, and xtel2 unconnected, fine. Ground is ground. Now VDDIO goes to 3.3. Yes. VDDCR only 2 blocking caps. Yeah, here is just one, and I decided not to populate it the second one. I don't know why. And today I think there shouldn't be any issue with the second capacitor. The original was for, yes, yeah, probably I didn't want to place and create another cap, but I think we can make some. We can dare to change the value to a similar one. Okay, so VDD R2 capacitors, then VDD1, VDD2 connected basically together and going to a battery of 3 caps and through ferrite bead to 3.3 3 caps. This one should be here along with this. Yeah, pardon my OCD, but I can't help myself. I can see that StreamYard today somehow improves my face, my camera view. I like myself better than before. I'm just joking. Okay, ferrite bead is here. And I call this line VDD-IO, which is used here. Yes, all pull-ups of the transmit. Yes, this line. Yes, this line is my VDD-IO. Which is an incorrect name because the correct name is VDD1 or 2. 1, 2. Because VDD-IO is here, not here. So pull-ups, all signals are protected against ESD events. The same pinout as in the original schematics. Yes, one important thing is here, differential pair, and we need to assign labels first. And then we can assign the net class. One possibility is to open the PCB editor, then go to file / board setup, then go to net classes, then create one. But today I want to investigate. Yeah, I was there zillions of times, but here is another option. File on Mac, schematic setup. I think on Windows or Linux is the same, but I'm not sure. Schematic setup, yeah, multiple tab or sub window, I don't know how to call it. And here is project and net classes. DP90 is for USB, I think, and I am not sure because I am a little bit confused. Let's ask what is the standard differential pair impedance of the Ethernet communication pairs DXP, DXN, etc. question mark. I think 80 or 100. I'm not sure. This is why I'm asking. 100, okay. So it will be differential pair underscore, which is my naming convention, 100R. This allows you to change the color of the nets, which can be useful. For instance, you can use 3.3 in red with different thicknesses. You can use 5 volt with another color and another thicknesses. You can use all differential pairs with other color. and you know, you name it, you understand. So can be useful. I have seen people on social media presenting their work using this. I'm not. Shortly, I have not used this yet, but yeah, why not? If you want to, let's say, make a less mess of the complex schematic, do it. Yeah, you can try it, and it costs zero. So yeah, my goal was to define the 𝗞100R differential pair, which is now defined. Now click on each label, go to properties or hit E button. Then yeah, here is the tricky part. It's not so obvious. You have to press plus. That class is the default property or default attribute that is added. Click on the value. Yeah, my cam is lost because of some issues, and this should be better, but I really don't know if it will work in this session. Yeah, this happens in the past, and it was because I connected the camera directly to the computer, and as some people reported on the internet, then the camera somehow makes issues. Edit mic setting, no. I'm back, my face is there, and screen is sharing, is being shared. So yeah, I hope this will work better. Yeah, I'm sorry for the issues, but yeah, I bought a magnetic connectors. Yeah, you can see. Oh, you can't see. Yeah, it's like Mac jack. You can buy these USB adapters. So I wanted to make a little bit like declutter my desk, because here is the USB hub connected to my Mac, and then the cable to the camera, but here obviously it doesn't work. 𝗞100 show name, because I want to show, yeah, just the show. Yeah, okay, this one. The same for all the labels. Usually I change the size of the 𝗞100 attribute just for the sake of clarity, not clarity. I don't think that the schematic is more clear with smaller fonts, but yeah, this time I will use the default size. Why not? Obviously, the Altium uses this nice and well-known symbol. We can make a workaround for it. For instance, we can define something like this. Where is the, yeah, something like this. And yeah, it's valid. It's valid signal name or a net class name, but as you can see, it's not like, oh, do you like it? I don't. We can place some symbols, maybe. For instance, I don't know. For instance, this one. Yeah, can we use it? I don't know. Yeah. No. Emojis are not allowed. So, yeah, DP100 works probably the best. Yeah, the change of the color is the 𝗞𝗶𝗖𝗱 when you leave the schematic and get back. Sometimes it get back to the purple, sometimes not. Ground directly to ground. Here is the EMC combination that is missing in the original schematic. Both cathodes of the LEDs are connected through 270 ohm to ground, and here is the unpopulated pull down of 10K from green anode. Yes, and this resistor is missing here. No, here is green anode. Yeah, here is the resistor. Okay, then there is a bias resistor 12K1 to ground, and this is here. So I think we have the correctly adapted schematic. So I can remove the review mark, and I can check the Ethernet as let's say done, or at least prepared for another review run. M2, let's get back to the original schematic, which is here, and here is the title page, and M2 is, can you help me? Probably no, because I won't hear you. Here, M2. Yeah, a lot of things here, signals mainly, and voltage dividers and connector. Their connector, M2 connector, is nice looking, fancy connector with all the signals named. My symbol is more simple, and you will see. I'm looking for the imported schematic to open the schematic page, copied here. Oh, it's a huge one, so I will change to A3. Okay, so let's start with the M2 connector, which is the most important part here, and I'm happy that they place here the spacer, the solderable. No, I want to be here. Solderable spacer, which will be Rego Electronics standoff. Yes, that's the thing, and I can see that Mauser have it. So okay, yeah, verifying of the device. I don't know what device they mean. I'm not a robot. Yes, this one. Yeah, this one exactly. I don't know why. DigiKey doesn't have it, but okay, even JLC PCB doesn't have it, but I will try. It's M2 standoff. Let's say M2 standoff, or here is the, yeah, I will need a data sheet. I don't know what is the diameter of the thread and the size. It looks like 4.2 high. Okay, M2 standoff. Standoff. How to find it? Okay. How to find some data sheet. Or drawing. Rego Electronics, yes. SSD. Yes, that's that's all I know, but I would like to Rego Electronics. Rego, Taiwan. Okay, we have another option how to find more about that. Multiple options. We can open. The DigiKey doesn't have it. We can open the imported project and look for the dimensions in the PCB, which can be the best way. Or we can open the Gerber, which can be option number 2. What do you like the best? I don't like any option. Any of them. So Gerber, open, docs, manufacturing files. No, we need here manufacturing. This is not what I want here. here Gerber and all files. Okay, work. M2 connectors should be here, and here is the standoff. Yes. I can see that open the imported project will be the best. Here is the copper. Select screen. I don't know what's the dimension of the diameter of the here. 6.5. The inner is 6. Oh, yeah, as you can see, such a simple thing completely disrupt the entire workflow. Screws. Amazon. Thread size M2. Okay, but these screws are for the sides to mount the disc into the chassis, not the M2 PCB. Okay, option number 2. Opening the imported project. Yeah, I have to, because it's important part of the design. And yeah, I have to admit, as I said, I don't have this component in my database. Yeah, the diameter is 4.15, so the description on the here, the description 4.2 is the diameter, like the finished drill. 6 is the outer diameter. Okay, that's everything. Yeah, and even here is the yeah, that's a good point. I have to place it correctly, but they measured it from this hole, which is stupid, because we need to place it here. Yeah, here is the shape of the board, and here is the center of the mounting hole, or the spacer. Okay, I think I have in my library these. So 4.15. Yeah, THT hole. If I had the drawing, I could or I would create a 3D model, but I don't have. Okay, M2. So this thing will be a subject of some new symbol and footprint, M2, which is here, and we say key E. This is key E. Yes, and still I would have to create a nice footprint or the shape. Yes, I have it somewhere, but I don't know where. Probably, yeah, I don't know. I will copy from the imported project. I'll copy it. It will be fine. So odd numbers on the left. And what I'm going to do is to copy the first group, to place it here, while immediately changing anything or everything that can be changed. Here is 0.0402, the same. Yes, so 100 nano. Here, this one. Twice. Okay, signals can be kept. Ground must always go to ground. Somewhere here. Signals. Here is the test point. Okay. Why not? I have plenty of test points. For instance, this one. Like, I don't know, say 10K to the ground. This one. Not to the ground, to 3.3. Yes. Okay, so the signals of the first group can work. The second group, all of them. Yeah, here is some collision because of these. Awful symbols. Okay, again. Yes. This should work. Shield is ground. Signal. Test point again. So I will use the same RTS. Signal 47K. Okay. I hope I will have. No, I don't. Never mind, I will modify it on the go. This one. Yeah. Not 15, but 1%. Yeah. A lot of work here. Okay. Okay, start again. Stock 47K, 1%. Okay, show me your funny. This one. And this one. 1% here. Just PCB code, manufacturer's order code is here, and datasheet is here. Okay, our symbol is updated. Yeah, I have to remove this. Update. Here. Yes. VDA1 V8. VDA1 here. Global symbols. I decided to use global symbols instead of the special power symbols, just for the sake of simplicity. Yeah, two similar resistors here, but we have to place the values and the different designator on the sides because of the position of the resistors. Here 3.3 was there. Yes, something like this. Can be signal unconnected. Okay, these will be, yes, our already placed capacitors here. For instance, this one. Yes, it works. It works for me. So the other side. Group number 1. Yes, signals, but I want to place them at the end of what just happened. Okay, test points 10K and yes. So this 10K, okay. Yeah, sometimes it's easier to place the component directly from the library because then the values and designators are in a better positions. Test points will be of the same type. And the name is the wake as well. VL wake. Okay, so this is BT wake and this is VL wake. Nice. Okay, this can be removed. And the ground is here, but I want it here. Yes. And group number 4, lovely group. Yeah. Oh, now I make my job more difficult because 35 is the first one. Yeah, I can easily lose the. So every other, okay. Not every other, every third. $75. Okay, and now the standoff. The extremely important part. Footprint, Jordan. Nice. Oh, here is the link to. Ooh. Some inner documentation link. Partial alternate internal part number. I don't want internal part numbers. I want external part numbers. Never mind. This is the MOC. And will be very similar to this one. This is M2 standoff with connection. Datasheet is unknown for 15. 6mm pad. MOC is this. Supplier is Mauser. GLCPCB, unfortunately, I don't know. I don't know how to find it. It's a 4.2 M standoff. They don't call it standoff. They can call it how? Spacer? No. Spacer is washer. Wafer. Okay, M4. Okay, so let's try M4, which is metric 4mm. Standoff is like pretty standard name, but the result, oh, here. Okay, not these components, but at least we can have a group, which is sometimes having female hex standoff. We have solderable, so hardware fasteners, and we want to have solderable solder terminal. Solder terminal. This is not solder terminal. Oh, this. Not so far from it, but not. I can't see anything. We want to solder the bottom part and from the top to have a female mating way. Through hole embedded round nuts. I don't know, maybe. No, this is for the plastic, for the 3D print. Single-ended head. Oh, single-ended hex stud. I don't know if it's a studder. Yeah, studder is a normal spacer. Surface no jumper knot. I believe female round standoff. No. Hexagonal nuts. No. I'm going through the most, yeah, the sections with most parts. Weld screw. Weld is a lot of parts, but nothing in stock. Male, female round standoff. I don't know. Probably not. Slotted round nuts, not. I think width have something. Or even, I think I worked some here. Something similar. Yeah, in the past I used it. Yes. Still a spacer with, yeah, something different but similar. So internal thread SMT spacer. They call it SMT spacer. Not space, but spacer. Oh, GLC PCB is completely off. Okay. So if width have this, the issue is that I don't know the height of the thing. No, I don't mean. I will keep this open, and I think I know a person who can answer this. to save time, I want to finish this. So this will be our footprint. This one, but will be slightly modified. Yes. Like this. And we want layers. Paste on top. Yes, mask and paste. Okay, that's what we want. Okay. Again, yeah, this is our thing. Okay, no data sheet, no JLC PCB code. And no position. Yeah. X question mark. Yes, so M2 is ready. Just let me check if it's still. Yes, this is it. This is it, and maybe Amphenol can have such spaces or recommend some M2 standoff. That's exactly what we need. Yeah, it was fast. No V, but Command V. Amphenol. Oh, I see. There are some missing characters. Here. This is it. Oh, lovely. See, that's it. Even with 3D model and even with datasheet. I love it. Amphenol. I love it. How much time have I spent? 30 minutes? I don't know. More than needed. Yes, this is it. Okay, I have to celebrate with some grapes. I guess the price is even lower. Now, of course, 3 times lower than from the Rego Electronics and with datasheet 3D model and twice as big stock. Okay, let's get back to work. I have to check the landing pattern. 4.2 and 7, okay. No problemo. This thing will be completely different. 4.2 and 7. Data sheet. I copied here. Here is this, and I believe JLC PCB will have it. Yeah, sure. Not in stock, but it has a database entry, so it means that you can somehow order it. Yes, definitely this is what we want. And symbol name will be M2 spacer M for 2. Yes. And now footprint again. I will keep this one because sometimes it can work. 7. Here 7, so 3.6, and this one is 3.55. Okay, and the most important thing on this is the 3D model, because it will help us place everything on its spot. So this can be deleted here. My library 3D models. Nice. Footprint 3D model. My library, yes. And now the name is MDT. MDT, this one. This one. Slightly low. I think this is it. Yes. Bye bye. Oh, it didn't crash. It just throw a bunch of nothing. I think it doesn't work. I think the footprint is not correct, but at least it didn't crash. Okay. This is it. Okay, so this will be changed. No edited. This will be changed to M2 spacer. Thank you. Yeah, it took quite a long time, but yeah, thank you for a piece of advice, but then you need to know what you are looking for. And I spent 20 minutes identifying the part number. If I had part number, that would be better, but I didn't have. Buses. A lot of buses. And we know how to do buses from last time. So this is the new bus with all this. So it was here, here, new bus, SAI1, and board numbers are SAI1, SCKA, then FSA, which is some kind of Russian. Oh, speak about Russians, fuckers. Okay. Now we have BT UART with signals. USART1 TX, RX, CTS, RTS. Okay, fourth bus is M2 control, so file, schematic, bus, and it's M2 control, M2 CTRL, I'm sorry, VL rec on, VL host wake, BT def, VL def wake, BT rec on, BT host wake, BT def wake. It's almost all signals are wake. LPO32, LP0, LPO, LP0, because as you can see the shape of this letter is different. So LP0. Okay, and the last one somehow damaged. Yeah, but by accident, not by intention. M2 as the MMC2. Will I use the MMC? I don't know, but I can define the bus. As the MMC2 CK CMD and D0, 1, 2, 3. D0, D1. Yeah, it's another, formally it's another bus, but I will split it into 3 because 3 signals or 4 signals are easy to draw. And now I have to basically create the buses. So for instance, this label is SAI1 is this bus. Now I have to connect 4. Yeah, but differently. This is better. Yeah, but yeah. Okay. So I will use this. I will create the this. No. Yes. This is the fastest way to keep the label at the end and now mirror them. Okay. Second bus. Again 4 signals, so I can inspire myself. BT UART, and now unfold from bus TX. RX. CTS. And RTS. Nice. The third one is with 7 signals, so a little bit longer. M2 control, but with brackets. Nice. And unfold. Break on. Wake. Another wake. Break on. Host wake. Def wake. And last but not least, P032. And the last one is M2 SD MMC2 with only 6 signals. So almost the same length as here. M2 underscore SD MMC2. And basically I can unfold everything. You have to always click multiple times. before the command is finished. Not super user-friendly way, but when you gain some muscles, bus muscles, it's easier. I don't know how to make it shorter. I'll keep it. I don't mind. Okay, so here are our 4 buses. Basically this. And now we have some voltage translators. 𝗶𝗶𝗖𝗱 I don't know if I have. This is the simulator. Yes. 𝗶𝗶𝗖𝗱 Yeah, I have some root, which is what's the footprint? This crazy. But I think they have UFN16, which UFN16, which is quad size, not quad size, quad shaped. Yes, this is my UFN. And this is there, which is I don't know which one is better. I will use my because I will. Two of them. VCCA is 3.3. VDDB is VDDA 1.8. Uh, 100K to 3.3 is the enable, and it's common to all. I'm studying this one. First two ports are from 3 points from A to B. And the third one is from B to A. Why they didn't use the bidirectional automatic direction sensing circuit? Oh, probably. Okay. Okay, I will have to solve it. So these signals are from first circuit for signals. This is called 1.8 enable. And there is 100K. To 3.3. Something like this. The outer or the other side, here are the signals, including the label. The first one, the second one is connected the same way, but it has different signals, obviously. And these signals are these. Okay, and now here are some interfacing, interconnections. Frankly, I don't know why. It will cause a lot of ERC warnings. Yeah, it doesn't hurt, of course, but I don't know. Okay. Now this one. The same small package. It's a level shifter with configurable voltage level shifting. So basically it's a three stage. Thinking something like not this one. What's the name of the 5? Yes, something like this, but this is 8. Yes, this is 8 port. This is 8 port. This is 4 port, but 2 groups, which is not an issue because they have two groups as well, which uses only one signal of the second group. And the question is the voltage level. It seems that this circuit can work. Basically, it's basically the same. Yeah, the same logic inside. AXC or AVC, yeah, that's okay. I will use this one. I have it, yeah. I have used it not last time. The package is slightly bigger, but I don't want to. Yeah. Yeah, I will fit it there. So the same direction, A is 3.3, B is 1.8. So we can use the same here. Output enable is common. Yeah, but just one. Pull up. Now the direction. Now the direction. They say that group number A, like 2 first signals are from A to B. So from A to B is high. Here, but because I clearly remember my mistake of the last time when I incorrectly configured this, I will obviously not here, but here. Yes. High, which is A to B. Okay, these signals will from A to B, and these two signals are these. While the VL wake in has pulled down. VL wake in okay. The fourth signal is not used, and the third one is from B to A. So the direction will be connected here. Okay, should work. This is our M2. Yes. Yeah, I will review it next time. Yes. So M2, I am 1.5 hours in the show, and I only finished M2. Yeah. Even with the grape topping. SD card. So imported project. SD card. Okay. This. It's a sorry. It's like, no. Flow through, yeah, flow through. Okay, so this is something like this one. This, no. Where are you? Here. Yes, the flow through. Okay. Just ESD protection. Okay. SD card, this one. BDD is not something, yeah. BDD is not to be connected through it. This one. VDD is VDD. VSS is ground. So 5, 7, 8. 9 is and how to call it? I don't know. CD is, here is the table. Card detect, yes. They don't use card detect. Why not? Okay. Yeah, this is the card detect, which is switch yes, it's internally connected. Yeah, when the card is inserted, the P6 is connected to P9. And the S1, 2, 3, 4 is what? Oh, shield, okay. Okay, now I know. So card detect, okay. card detect should be connected through this thing as well. So 6 is yes. I can change the pinout in the face of making PCB layout, working on PCB layout. This is the global shield, and this is the ground. LED flash. LED flash is from the PMIC. Yes, it is. Okay, I will save a label. So 47K to all of them but number 5. Clock is number 22 ohms near the view. One, two, three. Five. Seven, eight. And the chip detect, car detect. This one. And the bus. Yes. Called SD. Okay. CK, CMD, and micro SD detect. Yeah, I didn't use the prefix SD point. Just not a big deal. So SD. Okay, that's better than millions of interconnections. Okay, this ESD diode is inside of this. I didn't place this capacitor because it's useless. This power selection is correctly set. Yes. Yes. Yeah. Yeah, I'm just thinking that I can place the serial resistors even here, because it doesn't hurt. It only slows down the edges. It means lowers the probability of wave action, which is always a good thing. Oh, sorry. Okay. M2. Now, peripherals. We are almost 2 hours in the show. Yeah, short break. If you like what I'm doing, which I am not sure, you can support me. There are always ways how to support me. I created 2 online courses on 𝗏𝗏. Ticket for makers. You can create this nice RP2350 board with 2 digital inputs, analog inputs, bunch of LEDs, 2 power supplies, M2 connector, almost the same as I'm working now on SIM card, 2 USB-C connectors, with the advantage that if you enroll to the course, you will receive within 30 days a coupon you can redeem at the next PCB, and you will receive free PCBA. Not only PCBA with all the components. And it's valid for both courses. For beginners, essentials for KiCad, we will design this PCB with a simple power supply. And again, within 30 days, you can, or not you can, you will receive the coupon you can redeem at next PCB, and you will receive your PCBA. And if you check, for instance, this, as I calculated, the price of the PCBA is more than $100. And if you enroll the course, the least expensive is 69 euros. So I don't know, $75, $80. I don't know what's the course today, but what's the ratio today? But it means that if you enroll the course, you will receive the same value back. So I think it's no-brainer. But it's up to you. If you want to support me, I will be really happy. KiCad for beginners, KiCad for makers at 𝗏𝗏.com. Peripherals. Imported schematic. I will do it next time. I'm tired. Oh, it's not a big deal, but okay. Dip switches. Buttons, ESD. Okay, test points. For 3 identical buttons, user buttons, okay. A bus, boot modes, dip switches, okay, it's not a big deal. A table that can be copied, okay, as is. LED, okay, I will do it. It's not a big deal. For LEDs, 2 with switches, it means probably it's a bigger package. No. But still, there are some, small MOSFET, and the red one is driven directly from the port. I don't know why. I don't know why. Why? I don't know. Never mind. Maybe it's driven low, so they could use the NFET driver as here easily. I don't know. It doesn't make sense. Okay. What's the button width? Let's check the size. Yes, this one. So millimeters. Body is 6 millimeter times 4. Okay. Okay, I will have something similar. Tactile. Yeah. This one is already placed, but probably I will change to this one, because I have these in stock. It was here. No. Here? No, here. Yes. This one. Yeah. So, okay, they switch the VDD-IO. The user button switch directly the VDD-IO. Where there is the ESD protection and 100K along with. I will keep the same circuit, but I don't like it. And 100 nanofarads. Okay, the test points. Okay. So this is number 2. This is number 1. So this is number 1. And number 3 is not here because it's connected differently. Why? Why? I just don't understand. Inversely here is ground. Yes. No. I don't know what this is. I really don't understand. For buttons, a bus. Button. Buttons are ready. Now boot mode. This is the table. Dip switches. Another bus. Okay. I want this. This can be one. This is the one. Yes. 1K. The IO. We can't forget the USD diodes, because it can be deadly. Okay. This way is slightly more comfortable, because I don't need to finish the command, because when I place the label on the wire, it's already placed. So yeah, an alternative option. And LEDs. Another bus. Yeah, this time I could use, and even with the boot signals, I could use the generic definition of the bus, because there are only numbers, so it can be defined like LED bracket dot bracket, but never mind. So 4 colors: red, green, orange, blue, or yellow, blue, and a simple and MOSFET supplied from the VDD IO, and I will drive all of them from the transistor. I don't know why they didn't. So blue, green, orange, and red. Now the driver, no, the driver, the FET. And MOS. Hi, Manuel. Thank you for being here. I don't know. I am using only my my symbols of my library, so yeah, for me it's the same. But regarding KiCad 10, I think they removed some libraries and there are some extra libraries. So I think there are more symbols and footprints than in the previous versions. Blue 120. What's the maximum dissipation from 3.3? Not much. I will use 0.6, 0.3, but I have to create some new symbols. 300, 270 green. Yes, 270 green. They have 300 orange. I don't know. $300 is not in the range. 330. Red is 360. Forget 360. And blue is 100. Keep it simple, stupid. So the algae bus. Okay, there must be brackets. So blue is 4. Green is 2. Orange is 3. The one is red. It's a bus. It's not a label, it's a bus. Here you can define the buses, And if you want to tell KiCad that it's not a label like scalar, but it's a vector like a bus, you need to use the brackets on each side. And then KiCad knows that it's a defined bus with all these members. Okay, peripherals done. And I'm done too. Tired. Okay, we finished. Ethernet M2 is ready for review, SD card and peripherals. So next time we have to work on what? Power entry. Power entry. Yes, power entry and reviews. Okay, looks good. So power entry, and I will check what. Yeah, bus. But don't be sad. The part number 6, in the part number 6, I was studying how to define these buses. So I am like 2 lessons in front of you. Even I'm working on KiCad or PCB designs using KiCad every day. I don't use buses. I use labels and hierarchical labels and global labels, not buses. So I don't know, 2 weeks ago I had to learn how to use buses. So as I said, I am 2 lessons in front of you. So be happy and stay calm. So power entry, how do they use the power entry? Maybe they use the USB, this USB bus powered, this is the USB. Yes or not? Yes, VBus from the, yes, VBus from the USB. Yes. I will use a simple, yeah. Okay, we are done for today. 2 hours and 15 minutes. Schematic is not ready, but almost. Yeah, next comment. Comment. Do you have any advice for beginners like me? I want to try PCB design. Yeah. Yes, I do. Yeah, thank you for asking. I do. I have created 2 courses on Federavel, KiCad for beginners, which will learn you how to use essentials of KiCad, symbol libraries, footprint libraries, schematic capture, PCB layout, manufacturing data export, everything essential. There is a special offer. If you enroll the course, which is $49 or euros, the least expensive, within 30 days you will receive a coupon you can redeem at next PCB, and you will receive, if you order, you will receive your PCB-A. So not only PCB with all the components. The same for KiCad for makers. You will design this rather advanced PCB with dual-core MCU, 2 power supplies, bunch of LEDs, analog inputs, digital outputs, digital inputs, USB Type-C, SIM card connector, M2 connector, everything is there. The same. If you enroll the course, which is the least expensive is $69/euros. You will receive a coupon you can redeem at next PCB, and you will receive this or similar PCBA, which is worth of $100 plus. So you will learn, you will improve your skills, and you will receive basically the free PCBA, or you can say that you will order PCBA and you will receive the free course. It's up to angle of view. So yeah. Yeah. So if you already studied a KiCad course on 𝗶𝗶𝗀, try my courses or try another ones. Thank you. I have to tell that only my courses have this special offer that you will get your board free, not other ones, just my courses. Next PCB somehow chose my courses, and I'm happy for that. So yeah, take a look and it will support me significantly. So yeah, if you want, I will be happy. Thank you everyone. Thank you for being here. Next time I will finish the schematic and we will decide what next. Of course, component layout, etc., but it will be a long job. See you next week. Bye.